Hello everyone, welcome to my YouTube channel. I am Samuel Olushola, a software engineer from Lagos, Nigeria. On this channel, I'll be talking about all things software engineering with backend engineering being the main focus. In my first video here, I'll be going through why backend engineers will want to version their REST APIs, especially when they are building APIs for public consumption, where there will be a lot of clients who are going to consume their APIs and they don't have control over those clients. After going through the importance of versioning your REST APIs, I'll also walk through a NestJS implementation where we are going to create a very simple NestJS project and we are going to document that project with Swagger. That being said, let us begin. In software development, we know that change is constant, which means that our software changes over time. Unlike hardware, software is inherently malleable, which means software is easily changed compared to hardware. Our software is usually written as test documents that we can update and upgrade easily. And that is the reason why we have soft in software rather than hard in hardware, to indicate that software is malleable and it should be easy to change. Since we are talking about versioning APIs, it is important that we understand the vital role APIs play in software systems. They act as bridges that connect software systems. If you look at a server and client application, where the server provides some functionality that your client needs, your server can expose some APIs that your client will consume, and this API is acting as the bridge that connects your server and your client. If anything is to happen to that bridge, the communication between the server and client is broken. Over time, your APIs will evolve, and that might mean that you have to introduce some changes that will change the face of your API completely from what you originally intended. And while you are making those changes, you would want compatibility and smooth transitions. You will want clients that depend on your APIs to continue to work while you are making those changes that you need to make. That leads to one of the core benefits of versioning APIs, which is to ensure continuous client compatibility. As you have different versions of your APIs that have different changes, which may not be compatible with each other, your clients that are dependent on a particular version of your APIs, they are guaranteed that that version will remain the same, and any breaking change you want to make is going into the next version. Also, you have smooth transition to new features. Your clients can then transition to new features when they want to consume the new API and when they are ready. Especially when you are building public APIs, you can roll out features gradually when you are versioning your APIs. Without versioning, all of your clients are immediately impacted because you are pushing the change to the endpoints that they are dependent on. And that means that there are applications that depend on your APIs would most likely break. In addition, when you version your APIs, it means that clients can transition to new functionality at their pace. They are not forced to make changes when they are not ready to do so. Now that we have gone to the reasons why versioning is important and why as backend engineers, we want to ensure that we have different versions of our APIs, especially when we are pushing changes that can break the APIs. We have now come to the best part of this video, where we'll be going into VS Code and I'll be walking through a code demo in NestJS. See you in VS Code. In order to follow along, the initial code I'll be starting with is in this repository. You just have to clone it. I've already done that on my machine. Now I'll be moving to VS Code. The sample project is a simple NestJS project, and currently it has 3 modules: category, order, product. This project is an e-commerce like API where you can create a product, you can create an order that includes some products, and you can have different category of products. In this project, we are not going to be using any database. Everything is going to be written in memory. So let's go through a service. The category service, we have an internal memory here, an internal array. We have the category service. We have an internal array here that stores the category. When we want to get all categories, we just return the whole array. And when we want to create a new category, after receiving the payload from the client, we create a category object and push it into the categories. Then we return the category object that we created. The ID here is very simple. We are just using the date to generate the ID. If you look at the controller, you'll see we have the categories controller. We have two endpoints, get and post. The controller depends on the category service. For the get endpoint, we are calling the get or categories. For the post endpoint, after getting the payload from the body of the request, we just call the service with the payload. Let's go into the DTO to see the structure of the DTO. The DTO for creating category requires two properties, which is the name of the category and the description. We are also doing some simple validation to ensure that they are both strings. This structure, where you have the DTO, the controller, the module, the service, is similar across the three modules that we have. If we look at the order service here, we can see that we're also using an internal memory for storing the orders. And when we want to create the order, it's the same process as creating category. To keep this project simple, we are not going to use a database. For the create order DTO, this is the structure of the request that we need. We are requesting a user ID, an array of products, and the total amount for the order. The product itself is a class. Here, the product includes the product ID and the quantity. This here is for us to validate the nested products in this create category, create order DTO rather. We have similar structure for products. We have the create product DTO, which requires the name, the description, the price, the category of the product. We have the product controller, which calls the get all products from product service and create products from product service. So now, what we are going to do is first start up the server and check out what we have currently. I'm going to be testing with Postman. Now the server has started. We are starting the server on port 3030. Now we are going to Postman to test out the API. We are going to test out the create categories endpoint. It is a post request to localhost on port 3030/categories. Remember, we need to provide the name and the description. Here we have the new category created, and we can also get the categories that we currently have. It's a get request to /categories. Here we have the only category that we have created. If we create a new category, let's say we call this category 2, and we call this is description 2. When we do that, and we also test out the get, we are going to get the new category. So this is what we currently have. The first thing we are going to do is to first set up Swagger. To do that, I'm going to open a new terminal, and I'm going to first install Swagger with yarn. I'm going to be doing yarn add-d as NestJS Swagger. Now that Swagger is installed, we have to import the Swagger module and document module from the Swagger package, and then we have to configure Swagger in the Bootstrap function. I've copied the configuration from the NestJS documentation, and I'll paste it here. So we are building a new Swagger document. We are setting the title as e-commerce service. We are setting the description, and we are setting the initial version as 1.0. The server would have restarted, and we can access the Swagger documentation via the browser. So I'm going to do that. I'm going to localhost 3030/API, and now we can see the first version of the documentation. It is on /API because it was specified there that it should be on API. Now, one of the first things we will do is to go through the controllers, and we are going to use the API tags, which is imported from Swagger, to indicate that this is the categories. We're also going to the controller for product. We're also going to import API tags, indicate that this is product. The last one is the other controller, and we are going to do that at API tags orders. When we save this and then go to Swagger, let us refresh. After refreshing, we will see that the documentation has different sections now. Now we have a section for products, for orders, and categories. Let us try to create a product. From here, we can see that Swagger does not infer the schema. The schema here is empty. The fields in the DTO are not being displayed. We need to make some changes to our code base for that to happen. There are two ways we can configure Swagger to display the DTOs properly. One is to go to one way is to go into every DTO class and decorate it with the API property decorator from Swagger. That would require that we go into every DTO class and make that change. But if we want to do it more efficiently, we can configure the Nest CLI to apply the decorator automatically. So that is what we are going to do. So we go into Nest CLI configuration, and inside the compiler options, we are going to add plugins, and the plugin that we want to add is the NestJS Swagger plugin. Now this will require that we restart the server. Let us restart it. And that it has started, let me refresh. Now you can see that the schema is being displayed here now. Let's check the schema here. We can see that everything is required. That is why we have it in red. That is great. Now we want to add versioning to this API. The first version, which is version 1, we want to add that version to the API here. What we need to do is we need to go into the main.ts file. Where is it? That's main.ts file. And before we build the Swagger documentation here on line 12 here, we want to add this configuration for versioning. We are going to say app.enable versioning. Now, NestJS supports different types of versioning, which we can specify as the objects that we are passing here. In our case, we are concerned with the URI versioning, which we are going to do here as versioning type.uri. And also we will say the default version should be version 1. This is good. Now let us go to the documentation and check it out. You will see that now all of the endpoints are specified to be version 1, and we can try to run. Let's run an example here, categories. Let me try it out with random string. Okay, let me give it a category 1. This is a description. Then when we run it, we are going to see that the post request went to version 1/categories. Another thing we want to do is we want to prepend this with API/version 1/categories. To do that, we are going to set a prefix. In order to set a global prefix, we are going to create a file inside the source folder. We call it constant.cs, and we are going to export app. Let's call it API prefix as API. Then we go into the main file. After the call to enable versioning, we also want to call set global prefix, and then we import the app prefix. It is automatically imported here. So now we have set the global prefix to /API, which is defined here. We also can update the Swagger docs to be hosted elsewhere. Let's do that. We are going to say API prefix version docs. This is a syntax for Swagger to replace this key here version with the version of the document. Now let us check the documentation on Swagger. When we refresh, you would see that now this API is no more at this route. So what we need to do is we need to change this to say version 1. Yeah. So now we have our prefix at API/version 1, and the documentation is at API/version API/version 1/docs. Now let us test creating categories out with this. I'm going to try it out. Let me just try it out with what we have here. We can see that the call goes to API/version 1/categories. Now, fantastic. Now let's assume that this API has gone viral and a lot of people are consuming it. Then there is a new idea on how to create order, and we realize that this will require a breaking change to this create orders endpoint. What we want to do now is have a second version for create orders while this existing version continues to work. So we will go into the service first. We are going to create a new method. I didn't copy that right. So I'll call it version 2. Let's go into the DTO. Let's say the second version requires a new field. We are going to create that here, DTO version 2. And let's say the field is, what can I call it? Let's say we are collecting tag as a string, just to illustrate that this is required and it is going to break the existing endpoint. So we are going to use this create order DTO version 2 here. I'll change this to version 2. And I'll also log here console.log. This is version 2. Great. Now we will go into the controller. Let's open the other controller. And now we want to also expose similar endpoints here. We'll call this version 2 also. And I'm going to use the version 2 DTO here instead. This is great. And this will be create order version 2. Yeah. Now, because both of them are to the same route, to indicate that this is for version 2, we are going to come here and say version 2. This decorator is imported from NestJS common. Let us go to the documentation and see the updates. When I refresh, you would see we have 2 versions for the create orders endpoint. We have version 1, which requires the user ID, the product, and the total amount. And we have version 2, which requires user ID, product, total amount, and tag. Good. This is one of the ways we can have different versions of endpoints in APIs. Another way is to do that at the controller level. This is at the route level, because if we look at the orders controller, we are specifying the version here at the route level. To do something similar at the controller level, we are going to use the products controller as an example. Let me close everything here. I'll say we go to the products controller. I come here. To do that, let's create a new products controller for version 2. I'm going to duplicate this and name this products v2.controller, and I'm going to change this to products v2. We are going to be assuming that we are using a different service or different method in the service, just to keep this video short. The next thing that is important to do to make this a controller for a different version is to come to the controller decorator here. We are going to remove this and then pass in an object instead. We are going to say path would be product, and then we can specify the version to be 2. This way, this whole controller is for version 2. We now have to import this controller into the module as it is a new controller. We come here and we say part of the controllers is product v2. Now let's check the documentation. When I refresh, fantastic, you would see that we have version 1, and then version 2, version 2. One of the cool features Swagger should have is for us to be able to filter out this documentation by version. Currently, it is not possible. You can't filter the documentation by version. There is an open issue on GitHub. Yeah. But it is still opened. Hopefully, there will be a solution in the future and we can filter out different versions on the documentation. We have successfully created different versions of endpoints in this API, and we know how to do that at the route level and also at the controller level. One other thing we can do just to improve the code base is to separate this into different folders to indicate the version. For example, let's say under the product here, I create a new folder, version 1, and I put this controller inside of that. And let's say I do version 2 and I put this other controller here. So if there is a different service for controller version 2, I'm also going to add that here. So this way you have a structure for your code base that indicates this is for version 1, this is for version 2. I think VS Code will do automatic import from version 1. That has been done here. So I can go into the documentation and everything still remains the same. Fantastic. This is the end of this video. I hope I didn't bore you with too much details. If you enjoyed this video, please like, subscribe, and also share to increase the reach. And I'll see you soon. Yeah. Bye.